Most people look at a pile of cardboard boxes and see trash, something to throw away or recycle. But today we're going to turn ordinary cardboard into something much more interesting. Instead of throwing these boxes out, I'm going to try building a fully playable pinball machine. And not just something that looks like a pinball machine. I mean a real one. One with a launcher, flippers, obstacles, and a chaotic playfield where the ball can bounce around just like in a real arcade game. The big question is whether cardboard can actually handle the forces involved in a pinball machine. When a ball gets launched across the board and starts hitting bumpers and walls, there's a lot of energy moving around. Real machines are built from wood, metal, and strong materials designed to take thousands of impacts. Cardboard, not so much. So today's experiment is simple. Can we design a cardboard pinball machine that actually works and survives repeated gameplay? Let's start building. The first thing every pinball machine needs is a strong frame. Even though cardboard seems light and flexible, when you layer it correctly, it can actually become surprisingly strong. Corrugated cardboard has those wave-like structures inside it, and when multiple layers are glued together, they can support a lot more weight than you might expect. To start, I cut a large rectangular base that will hold the entire machine. But pinball machines aren't flat. They need to sit at an angle, so gravity pulls the ball downward toward the flippers. Without that slope, the ball would just stop moving in the middle of the board, so the base needs to be slightly raised in the back. I added several stacked cardboard layers underneath the rear of the frame to create an angled surface. It's not a huge angle, but it's enough for gravity to do its job and keep the ball rolling. Next come the side walls. These are important because they keep the ball contained within the playfield. In a real pinball machine, the ball constantly hits the side rails at high speed. That means these walls need to be reinforced so they don't bend or collapse after a few hits. To solve that problem, I doubled the thickness of the cardboard walls and added extra supports along the edges. By gluing several layers together, the structure becomes much more rigid. Once the frame and walls were attached, the machine finally started to look like an actual pinball board. But it still needed one of the most important parts of the entire game, the launcher. The launcher, also known as the plunger, is what sends the ball flying into the playfield. In real machines, this uses a metal spring that stores energy when pulled back and releases it instantly when the player lets go. Since we're building everything from cardboard, I needed a different way to create that same effect. Rubber bands turned out to be the perfect solution. By attaching several rubber bands to a sliding cardboard rod, I created a simple spring-like mechanism. When the rod is pulled backwards, the rubber bands stretch and store energy. When released, they snap back to their original position and launch the ball forward. It sounds simple, but getting the strength right took a bit of testing. Too little tension, and the ball barely moves. Too much tension, and the ball might shoot across the board so fast that it damages the cardboard. After adjusting the number of rubber bands, the launcher was finally ready for its first test. And it worked. The ball shot forward across the board much faster than expected. That was a good sign, because it meant the launcher had enough power to make the game interesting. But now the cardboard would have to survive the impacts. Next up are the flippers. Flippers are what make pinball a skill-based game instead of just random bouncing. They allow the player to hit the ball back up into the playfield and keep the game going. Building functional flippers out of cardboard is definitely one of the most challenging parts of this project. To make them work, I created a simple lever system. Each flipper is made from several layers of cardboard to keep it stiff. The flipper rotates around a small pivot point so it can swing upward when the player presses a button. On the sides of the machine, I added push buttons made from cardboard sticks. When pressed, these sticks push the lever mechanism connected to the flipper. Rubber bands are attached to pull the flipper back down after each hit. This creates a basic mechanical system where pressing the button snaps the flipper upward and releasing it resets the position. After a few adjustments to the alignment and rubber band tension, the flippers were finally ready to test. The ball rolled down the board, reached the flippers, and with a quick press of the button, the flipper launched the ball right back up the playfield. That moment proved the concept worked. Now the machine just needed something to make the game exciting. A pinball machine without obstacles would be pretty boring. The whole fun of pinball comes from watching the ball bounce unpredictably around the board. So the next step was building the playfield. For bumpers, I used plastic bottle caps glued onto the board. These act like small barriers that the ball can hit and bounce off in different directions. Then I added a few cardboard ramps that redirect the ball upward before dropping it back down somewhere else on the board. I also created small tunnels and angled walls that change the ball's path. Each obstacle adds a new layer of unpredictability to the game. Designing the layout took a bit of trial and error. If everything is too crowded, the ball might get stuck. If it's too empty, the ball will just roll straight down. The goal is to create controlled chaos. Every launch should feel slightly different. Once all the obstacles were installed, the machine was finally ready for its first full gameplay test. This was the moment where everything could either work perfectly or completely fall apart. I placed the ball in the launcher, pulled back the plunger, and released it. The ball shot forward, hit the first bumper, bounced off a ramp, rolled toward the flippers, and then got launched right back into the playfield. It was actually working. The cardboard walls held up, the bumpers redirected the ball, and the flippers kept the ball alive just like in a real pinball machine. After several rounds of testing, a few weak spots did start to appear. Some of the bumpers needed extra glue, and one of the flippers needed stronger rubber bands to snap back faster. But those were easy fixes. After reinforcing the problem areas, the machine was ready for a final stress test. Multiple launches, faster gameplay, more impacts. And surprisingly, the cardboard structure held together through all of it. For something built mostly from recycled boxes, it performed far better than expected. This project shows that simple materials can sometimes do amazing things when they're used creatively. Cardboard might not seem like a strong building material, but when layered and reinforced properly, it can support surprisingly complex mechanical designs. Turning a pile of discarded boxes into a functioning arcade-style game is a great reminder that creativity often matters more than expensive materials. And honestly, playing a game on something you built yourself makes it even more satisfying. But this raises an interesting question. If cardboard can survive a pinball machine, what else could we build from it? Maybe a cardboard claw machine, a mini arcade cabinet, or something even more complicated. If you enjoyed this experiment and want to see more creative builds like this one, make sure to subscribe to the channel so you don't miss the next project. Because this cardboard arcade experiment might just be getting started.